Okay, so hello everyone, welcome. Okay, so just we are waiting 1 or 2 minutes for joining all of those other participants, then we'll start. So in the meantime, I also give you an announcement for our upcoming online training program, which will be held on the 8th December. So basically, this online training program, you learn all of those things from beginners to advanced level on Google Earth Engine platform. So basically, it's a total 7 days online training program. So mainly Friday and Saturday, we take the class, and class duration for each day 3 hours. And this is the time about that. And basically, in this online training program, you learn all of those things from beginners to advanced level. And if you have no knowledge about the programming, if you have no knowledge about the Google Earth Engine, don't worry about that. We start from the beginners level. So in this time, first of all, you will learn all of those programming languages and also learn how to apply this type of programming language in Google Earth Engine platform for different types of remote sensing analysis, such as land use land cover mapping, land use land cover change detection, air quality monitoring, time series surge analysis, calculating any indices, how we can easily apply the different types of machine learning. So all of those things we try to complete. And here you can see this is our course content about that for each day. So I already added all of those video, all of the description in the video description. If you want, you can easily check it from the video description. Okay? And if you want to join this online training program, you can also get some benefits, such as you can get the certificate, as well as you can get all of this PDF slide. You can get all of this practice code, also recorded video class, and get the lifetime teaching support. It's very important for that as a newer. If you don't do knowledge about the Google Earth Engine or programming, you face a lot of problem. So that's why you need the continuous guideline for that. Okay, so for that, in this time we also provide about the lifetime teaching support, so that you can easily get the continuous support to learn the Google Earth Engine for your remote sensing analysis. If you want, you can simply contact in the WhatsApp number, as well as you can also contact with the email, and simply complete your registration and then simply join in our Google Classroom. Okay, for the upcoming batch, you can simply join our Google Classroom, and then further you can easily get from here. Okay, so if you want to join, then simply contact this WhatsApp number and also email, then you can get all of those things. So thank you. Okay, so hope hello everyone, welcome. Can you hear me? Hello. Okay, so I hope you can hear me. Yeah. Okay, so okay, thank you. Okay, okay, so let's go about that. I simply share my screen. Okay. So first of all, I will describe a method. Suppose how we can easily improve the accuracy of our land use land cover classification map. Okay. So suppose here you can see this kind of one kind of map, land use land cover classification map. So mainly it classified a lot of uh, classes, such as water body, agriculture, forest, vegetation, settlement, barren land, wetland, and also this type of classes it classified. Okay. So now if I want to check this type of, you can see for the training accuracy. Okay, basically we can get the two type of accuracy. One is the training accuracy, another is the validation accuracy. Okay, and mainly validation accuracy is very important because your map accuracy is mainly depend on your validation accuracy. If I get the low value, it means that your map is not properly correct. It's just misleading about the pixel value, and mixing with each other. Okay, so in this time, there's a lot of way to make the develop the accuracy. So basically, in this time, I talk about this method. So basically, you can see this method is that how we can easily find out the hyperparameter tuning to improve the accuracy for machine learning model. So mainly random forest, how we can easily find out the decision number, what is the actual value. Okay, when I put this value, then I can get the better accuracy. So it's called the hyperparameter tuning. And we are using the hyperparameter tuning to develop in our accuracy. Okay, so as well as another way is that if you want, suppose in this time here you can see here I add some external band. Okay, so previous class I also discussed about that, how we can easily add this type of band, such as here you can see NDVI, NDBI, MNAWI, BSI, EVI. So when I use this type of band, it also increase the accuracy. Suppose I give you an example without this type of band, what the accuracy I can get. Suppose I simply remove this type of band and I want to check what's the accuracy I can got when I simply remove this type of things. So now click to the run. In this time, without this type of band, such as NDVI, NDPI, or NDWI. So this type of band without this type of index, what's the accuracy I can got for this map? So in this time, you can check the accuracy from here. Suppose I'm calculating the okay. Okay, so here we can get this type of accuracy. You can see we can get the accuracy is the 76%, and we can also get the kappa accuracy is that 71%. Okay, without this type of band NDVI, NDPI, MNAWI, BSI, EVI, without this type of band I can get the 76%. But when I add this type of band, suppose I simply add the band for NDVI, also add for the band for NDBI, mainly build up index, and then also add here for MNDWI, as well as also add for this another band, suppose BSI. Also add here another band, suppose enhanced vegetation index or EVI. Okay, so now check what is the accuracy we can get after adding this type of external band. So basically this type band is the external band, and this type of red, green, blue, near infrared, short wave infrared. So this type of band we can easily get from the satellite images. But NDVI, NDPI, MAWI, BSI, and EVI, so this type of band we need to create using the different types of equation, such as EVI, you have to need to put the equation for the EVI, or NDVI need to put the NDVI equation. So now we check the validation accuracy. We can get the accuracy. You can see it increase. Okay, we can get the 84% accuracy. Okay, so now it's improving the accuracy when I add this type of external band. Okay, and also increase the kappa. You can see 80%. Okay, so it's the one way to identify or improving the accuracy. Okay, suppose B2, B3, B4, this type of band is already available in your satellite images, but this type of band is not available in your satellite images. So for that, first of all, we need to create this type of band. And how we can create this type of band, I already show you the previous class. So then simply add this type of band, then we can see that this type of accuracy is also improved, the accuracy 84%. So this is the one way. Another is that it's called the hyperparameter tuning. Suppose in this time, if you can see my model, in this time we are using here the random forest model, and in this time I put here the decision tree number is the 101. Okay, I randomly put it. I don't know what is the actual value for this model. When I put the value, I can get the better accuracy. I don't know. So for that, in this time, we need to calculate what's the accurate or what's the best value for this model. When I put this value, then I can get the better accuracy or best accuracy. So in this time, this type of value called the hyperparameter tuning. So in this time, I show you that how we can easily calculate the hyperparameter tuning and find out the which value is better for this model, and then value when I put in here, then I can get the better accuracy or best accuracy. So let's go how we can easily calculate this type of value. So I write the code in here for identify this value. So first of all, I don't know what's the decision number trees. What is the number of decision number trees I need to put in here? I don't know. So for that, first of all, I just make a sequence. Suppose I make the sequence, suppose 10 to 200. Within this value, 10 to 200, I choose a value, and this value is for the best. When I put in here, then I can get the best accuracy. So for that, I just take a variable. Suppose I put the variable name is that, suppose number 3 list. Okay. In this time, I just make a list about the number of trees. Suppose put at the start from the 10 and up to suppose 300. Okay. Start from the 10 and up to 300, and then I set the interval, suppose 10 or 20. Okay. So then it moved to the 10, then also go to the 30, then also 50. So interval is the 20. If you want to also set the 10, there is no problem. So basically, it's my initial value and it's my in value. Okay, and it's the interval every step for the 10. Suppose 10, then 20, then 30, then 40, then 50, then 60, up to 300. Okay, or if you want, you can also put at the 20. Then what will be done? So first was initial value 10 and final value 300. And what is the interval for every step? 20. Suppose 10, then 30, then 50, then 70. Okay, this type of step, and up to 300 it will be go. So in this time, so just I make the number of trees list. Okay, so now I want to check what is the accuracy, what is the best accuracy, what is the best value between the 10 to 300. What is the best value to get the better accuracy? Okay, so for that, in this time, I need to make a function, and in this function, I need to calculate the accuracy. Okay, suppose I just take a variable, suppose accuracy, and now I just simply make a function. So just put here the function keyword. In this function keyword, I just simply put here the element name. Suppose I put the element name, suppose number 6, and then make the curly bracket. In this curly bracket, I need to define. So in this time, I just create my algorithm. Mainly, I create my model, such as random forest model. And in this random forest model, I don't put any value. Okay. So in this time, it automatically take all of those values. Suppose 10 to 300, all of those value automatically take and check the accuracy. Okay. So just take a variable. Suppose I put the variable in the classifier. In this classifier, I just call my algorithm dot classifier dot smile random forest. Okay, forest. In this time, you can see first of all number of trees. Okay, in this time I don't put any value in here. Okay, so in this time all of those values, suppose 10 to 300, interval is that 20 for every step. All of those value come in here and check the accuracy. Okay, so in this time I don't put any value. Okay, because in this time I put the list. Okay, this list including the, start from the 10 and up to 300 and every step for 20. Suppose 10, what is the accuracy? Suppose when I put here the 10, then what the accuracy I can get? Suppose when I put here the 30, what the accuracy I can get? Suppose when I put here the 50, what is the accuracy I can get? So in this time, it automatically come. So one value will automatically come and then calculate the accuracy. So for that, in this time, I just simply remove all of those argument. not need for this time. I simply remove. And then call my this element name. So simply copy and paste. Okay. So just I simply define my element name, and now I want to train. So in this time I just train it. Suppose for that we'll just put here the train function. Train. We already discussed about the train. In this time I train my data set with my 80% data, which I already separate. So just simply make a curly bracket start and also curly bracket in here. So now first of all feature. So in this time we can see feature. So mainly this feature is that 80% data, which I already separate. You can see I already separate the train set. Simply copy the variable name and paste here. Okay. And class property, we already defined the class property. If you can simply go here, you can see this is the click on here. Then you can easily get the class property name is the class. Simply copy the class and then paste here. Okay. So input properties mainly it's all of those band. Okay. And we already define all of those band. You can see in a variable, we already define all of those band. So you can see this is the variable bands. Okay. This variable is stored all of those band in here. So just I simply copy the variable name and paste here. Paste here. So now in this time it's not need, I simply remove that. Okay, so that's like train my model with 80% data. Okay, and now from here I just return my test set. Okay, so in this time I already defined my test set. You can see this is my test set. Simply copy the test set and then paste here. And then I just this test set classify. So just use here the classify with the model. Model name is the classifier. Simply copy the classifier and paste here. And then find out that error matrix. So just here the error matrix and put here that actual value is the class. The actual value class mainly this actual value mainly is the your property name. Okay, which you set in here. So is the class, and we can get this from the classification. Just set the classification. Okay, so now just simply use the function accuracy. Just use here the accuracy. Okay, so now in this time it calculated the accuracy. In this time this is my function. Okay, and this is my number of trees. Okay, so in this time now I put here the element name, but I don't define any number of trees. Okay, all of those number of trees I just make a list. I want to check for every number of trees what's the accuracy I can got, and it already stored in this variable. I simply copy this and then paste here, and now connecting using the map function. Use here the map and close the parent. Start the parenthesis, also close the parenthesis. So now all of those number of trees connecting with my number of trees, and then make the accuracy. Suppose for the 10, what's the accuracy I can get? For the 50, what the accuracy I can get? Okay, for the 70, what the accuracy I can get? It will be start from the 10 and up to 300, and every step is the 20. Okay, so now I want to display the result. For that, I just make a chart. So for that, you can simply use a function. Suppose UI chart dot array values, and put all of those things in one by one. So just make a curly bracket start and also curly bracket in. So first of all, array. So what is the array? Array mainly it is represented about that the accuracy. Okay? So just I simply put here the e dot array function, and then call this function variable name accuracy. Copy and paste here. As well as we are just put here the axis. Okay, so in this time we can put here that 0. There is no problem. And x level, I just put the x level. X level mainly it display the this type of number. 10, 20, 10, 30, then 70, this type of number. I simply copy this variable name and paste here. Okay. So now give a variable name in here. So var, suppose put the variable chart. So in this time I simply display the chart. Suppose use here the print function and then call the chart. So now you can check what happened. You can get. Okay, let me check the number of tree list is not functional. Okay, it's another thing is that in this time we have to use here the server function. Okay, so for the server function we are just put here ee dot list dot sequence. Okay, so this is the server function. So now let's check. Okay, so now it's generating the chart about that. Okay, so now you can see we can get this type of chart. In this time, here you can see we can get the chart is that we can get this type of it's mainly your value. Okay, suppose it's mainly the decision number of decision. Okay, so you can see when I put here this 10, then I can get the 81% accuracy. Okay, when the number of decision I put, I can get the 81% accuracy. Suppose when I put here that 30, then I can get the 83% accuracy. When I put here the 50, I can get the 84. When I put here the 70, I can get the 84. When I can get the 90, then I can get the 85% accuracy. Okay, also you can see. So every accuracy with that decision number of trees, we can easily get from here. So in this time, we are get the best accuracy. I think it's that in this time, this is the highest point, 210. Okay, when I put here the 210, I can get the 85% accuracy. Okay, so for this model, my number of decision trees value will be 210, and it's the hyperparameter turning. Okay, so in this time for my model, here you can see this is my model. In this time when I put here the value, suppose 210, then I can get the 85% accuracy. Okay, so now let's check about that. Suppose 210, I simply put here the 210, and now check about the accuracy what we can get. In this time we can get the 85% accuracy for this. So now it also improving the accuracy. So this is the another way to improve the accuracy. You find out the hyperparameter turning. Check our validation accuracy. Okay, so now here you can see we can get the result is the 85% accuracy. Okay, so this 210, this value is that hyperparameter turning. Okay, number of decision trees. And when I set this value, then I can get the best accuracy 85%. and also increase, you can see kappa accuracy 82%. So this is the another way to improving the accuracy of your land use land cover classification. Okay. So anyone any question or any doubt, you can ask me about that. So using this is the way to identify about that hyperparameter turning and also improving your accuracy. And another way is that you can simply add the more external band such as NDVI, EVI, or barren soil index, as well as also other types of index you can easily add, and then we can easily get the better accuracy for your land use land cover classification. So this is another way. So mainly this is the two technique we are used to improving the accuracy of our land use land cover classification map, as well as you can simply properly put your just take the training sample from the satellite images carefully. And so basically this type of technique you can use, and then you can easily improving your accuracy. So just try to find out the hyperparameter turning, as well as you also try to add here this type of external band NDVI or MNWI, BSI, EVI. Okay. Then when I add this type of band, then our data set will be more strong. Suppose in this time you can see here you can get this type of here you can see total 2296 training point. Okay, so all of those training points extract the pixel value for all of those band. Okay, suppose in this time you can see this is the individual band. Suppose this training point extract the all of those pixel value which I add in here. Suppose B2, B3, B4, all of those band pixel value extract and make the very powerful data set. Okay, and now we can easily suppose for the vegetation we can get the vegetation agriculture. Okay, agriculture, forest, vegetation. So basically this type of classes pixel value almost same. Okay, vegetation, forest, agriculture, so a spectrum chart is almost same. But when I add the NDVI then also we add the EVI, also SAVI, then we are also get the more distinguished between the agriculture, forest, and vegetation, and then it also easily classified. This is the vegetation, this is the forest, this is the agricultural land, as well as settlement and barren land. Suppose settlement and barren land, also wetland. So this type of classes spectrum is the almost same. Okay, but when I add here the NDBI, mainly normalized difference build up index, as well as also barren soil index, then it also more distinguished between the settlement, barren land, and wetland, and also improving our accuracy of the land use land cover accuracy. Okay, so I hope you can got this point. Any question or any doubt? Okay, okay. Okay, so I also send you this code. You also try to practice this code for your own project, and then after that, face any problem regarding any issue, just contact in our WhatsApp group. Problem. Okay. Okay. So now I talk about that another code. Suppose. Okay. So now I talk about that how we can easily make the change detection land use land cover classification map. Suppose here you can see here I already make the classification of the land use land cover classification map for the 2 decade. Okay, so one is that 1991 and another is the 2021. Okay, so 1991 and 2021. So now I want to make the change detection map, as well as also calculate the transition area for how much build up area, or how much barren land convert into the build up area, or how much vegetation convert into the build up area, okay, how much water body convert into the vegetation. So this type of analysis for calculating the transition area, how we can easily calculate it, we also try to discuss about that. Okay, and how we can easily make the land use land cover classification map. Previous class I also discussed about that. I hope we can easily make the land use land cover classification map, and also improving the accuracy. After that, in this time I show you that how we can easily make the change detection. Okay, you can see this is the map about the year of 2021, and it is a 1991. Okay, so this is a 1991. Red color identify about the build up or settlement. This is the vegetation. Okay, and blue color identify about the water body. So and yellow color is the barren land or others. So in this time, we can see that in the year of 2021, it increased a lot of build-up area or settlement. Okay, so these were 2 decade land use land cover classification map. So now from here, we are just make the change detection map. Okay, so in this time, for the making the change detection, we can apply the two way. If you want, you can just use the single class change detection, or if you want, you can also multi-class change detection. Now, what is the single class? Single class, suppose when you want to make the only single class, suppose you want to identify for that settlement. Okay, so mainly it work for that when you want to work for the urban expansion for the different time period, it's very useful. Okay, suppose urban development, you want to make the urban sprawl map. So these type of things, we are just apply this type of technique. So in this time, suppose I want to make the suppose urban pattern change or also make the urban development for the different time period. So you can see first time we can get only for this, it is the urban area or build up area. But when I want to simply year of 2021, I can get lot of urban area, lot of development. So now I want to make for the single class change detection and then also show you the multi-class change detection. So let's go. So here I already create this type of map. So let's go. Okay. So in this time, so let's one by one I write the code later, so better. Okay. So now, first of all, suppose I want to make the change detection for the build up area change detection. So for that, suppose I just need to create for the single class map. In this time here, you can see it show the build up area, vegetation, barren land, water body. So in this time, I just create the single class map. Okay. So in this time, for that, I just take a variable. Suppose I put the variable name is that suppose build up area, suppose 2021. Okay. So in this time, first of all, I need to separate the build up area. Okay. So in this time here, you can see this is the map, LULC map for 2021. Okay. And this map is already stored in a variable. Okay. This map, year of 2021, land use land cover map, already stored it in a variable. I need to find out what's the variable. Okay, so let's go. This variable is that in here, you can see. Yeah, so you can see LULC 2021. Yes, this is a layer name LULC 2021, and it is stored in this variable classified RF 2021. Simply copy this variable name and then paste here. So now I want to work only for the settlement or build up area. So that's why I just need to equal the build up area value. Okay, what's the build up area value or settlement value? You can simply check it. You can see the build up. So also here the build up. You can simply click on here. Then we can get the build up is the 1. Okay, build up value is the 1. Also you can see the suppose build up for 2021. You can get the same value 1. So in this time I just simply put here that 1. Okay. So now what's in this time? This variable stored the full land use land cover classification map. I just put here the equal to 1. So in this time, this variable is stored only for the build up area because I set equal to 1. And 1, what is the value about the 1? 1 is for that build up area. So now let's display the only for the build up area map. So just I simply use here the map dot add layer and then simply copy the variable name and paste. So now in this time, it show the result only for the build up area, only build up area, not other class. So I just set the color about that. Suppose mean it will be start from the 0 and also put here the max up to 1 and then put put here the plated. I just make the plated. Suppose where there is no build-up, it show as a gray color, and where is the build-up is present, it show as a red color. Okay. I also give the layer name. Suppose build-up 2021. So now click the run. So now in this time, it show only for the build-up area map year of 2021. So this is the process when you want to separate for any class. Suppose you need to separate only for the vegetation. Suppose you want to make the vegetation change detection map, okay, or water change detection map. So these type of things, just you can simply separate the vegetation map, okay, then make the change detection map. So in this time, I show you the build-up area, and I also display the only for the single class build-up area map year of 2021. Wait, I mean. Okay, so now you can see we are just make the map only for the build up or settlement. Okay, and other class show as this type of gray color. Okay, gray color is the other class, not build up. So in this time, here we can get this type of map. So mainly you can also represent this map as a build up map year of 2021. Okay. So now suppose in this time, you just need to calculate the area. Suppose you calculated the area, how much build up area is available in here. You need to calculate the area. So in this time, we are just calculated the area. And previous class, I also show you this one technique, how we can easily make the calculated the area using chart. Suppose in this time, I just add the bar column chart and then calculated the for each class area. But sometime we faced some problem. It show the maximum limit exists and also show that there are the lot of pixel value. So then it show the some problem for creation of the chart. So that's why we also need to learn about the manual method, how we can easily calculate the area. Okay. So now talk about the single class area. Suppose in this time, the build up area, I want to calculate the build up area class. How much area for the build up area, this map, I want to calculate that. So very easy. So let's go. Just take a variable. Suppose I put the variable name is that, you can put any variable name. Suppose I put the variable name is that of area, suppose 2021. Okay. And this build up area mainly stored in this variable. You can see equal to 1. Once means build up area, because I was just put here the is that this is the 1. Okay. So that's why it is the build up area. So just I simply copy from here and then paste. Okay. And now this I need to connect a function. So for that use here the multiply. I just multiply a function. This function called ee dot image dot pixel area. Okay. So in this function mainly calculated the pixel area in square meter. Okay. So let's go about the result. So for getting this result, we have to use a function reduce region. Okay. Lot of time we are using the reduce region function to calculate the average, maximum, minimum, or standard deviation. So mainly reduce region. This function calculated for the any kinds of statistical such as maximum, minimum, then average, total, standard deviation for any specific boundary. So in this time, my main target is that in this boundary, I want to calculate the total area of this pixel value, build up area, pixel value, total area. So for that, I just take a variable. I put the variable name is the suppose area 2021. You can put any variable name. There is a no, but they use the same variable. I simply copy the variable name and paste here. And put the reduce region. Okay, so mainly this function calculated for any statistical value for a specific boundary. Okay, so put here the all of this argument one by one. Just make a dictionary, curly bracket start, and also curly bracket int. So first of all, here you can see this is the reducer. In this time, I just need to calculate the total area. Okay, so just put here total ee dot reducer dot sum total area. Then geometry. Geometry is your specific boundary. This specific boundary, mainly this boundary shape file. So what is the boundary shape file variable name? You can see this boundary shape file is the AOI. Just I put here the AOI. Just put here the AOI. Then scale is the resolution. So just put here the 30-meter resolution for Lancet 30 meter. So now it not I simply remove that. So now simply print this value. Just simply print here the print function. Print area 2021 copy. So now check the result about that. What is the total area for the build up area in 2021? So here you can see it calculating the area. So here you can see this is that about that. Okay, we can get this type of result. This unit is that mainly square meter. Okay, so in this time, we are just convert it as a suppose a square kilometer. Okay, it's the result show as a square meter. I want to convert it. So how I can convert in here? Very easy. Just take a variable. Put the variable name suppose urban area square kilometer. You can put any variable name. After that, it's a number. Okay, it's a number, and this number is stored in this variable area 2021. Okay, so this number is stored in this variable. So now I just simply use a function ee.number. So basically it is the server function. When you define any number, we are just use here the ee.number, and this number is stored in this variable area 2021. Click copy and paste. After that, you can see this number, mainly this classification value. Okay, classification keyword, and this is the value about that. So this is a classification. So in this time, just put a function get, mainly this it's come from this classification. Simply copy the classification and paste it. Okay, and then finally we are just simply divide 1 into 10 to the power 6, or scientific notation is that 1e6. Okay, so now it convert into a square kilometer. So now let's check the result. So print, simply copy that urban area square kilometer and then paste here and click to run. So now it display the result. You can get, I can see 74 square kilometer. And this time you also get some this type of floating number. If you want, you can get only for the integer value. Just use a function, round function. Okay, so then we can get the round figure as an integer value only. run. So now we can get the round figure 25 square kilometer. So now suppose you can just apply the same things also for 1991. I just simply copy the same code and try to apply for the 1991. Then paste. In this time, you can see I want to calculate the build up area for this map. Okay, this is the map about the 1991. So this map I want to calculate that total area of settlement or build up area. So in this time, I just find out what is the variable name about this map. Okay, LULC 1991. This what is the variable name about that? So you can simply go to the app, then we can easily get that. Yeah. So you can see LULC. This is the layer name. So this layer name LULC 1991, and it is stored in this variable. Click copy and then paste here. Okay. And I will change the variable name. Suppose I put here the 1991. So then put here the 1991. One is that for build up. You see build up. If I use here the same. After that I simply copy the variable name and paste here. So then I simply put the layer name. Suppose build up 1991. Then build up. I will calculate the area. So for that I simply put the build up variable name. Suppose 1991. And simply copy the same things. Okay, just apply the same approach. Paste here. After that, I calculate the area. So just put here the 1991 and simply copy the variable name here. The reduce region function, same. And simply copy that. Paste. I put the urban area square kilometer. Suppose 1981. Then simply copy the variable name and also paste. So then divide, and then I simply copy the variable name and then so now it display the result about that urban area for 1991 and also created the urban area map for 1991. So now check the result. Okay. So here you can see we can get that 5. Okay. So 5 square kilometer urban area in 1991. Okay. And it we can get that it increasing that 75 in year of 2021 square kilometer. Okay. So in this time we can get this type of things. So now I just make the change detection. You can get the two maps. Suppose you can see the build up 1981. We can get only for the build up area map. It shows only for the build up area map in 1991, and this is the map for build up area 2021. You can see. So now in this time, I just calculated that make the change detection. Okay. Suppose in this time you can see for this region, its build up area is available for the 1991, and for the 2021 it also available. Okay. It also increasing. So for this time, for this build up area, there is the no change. Okay. Suppose it also increasing for the build up area. Okay. You can see it also increasing or expansion. So in this time, I just make the change detection map So for that, what can I do in Google Earth Engine platform? So for that, we are just take a variable. Suppose I put the variable name is that changed. So for the changed in this time, we have just called the after class subtract with before class. So in this time, after class mainly it is that year of 2021. Okay, and before class is mainly it is the 1991. So after mainly present 2021 after, and before 1991. So in this time I simply call the after class. After class mainly I already make this map. So this is the after class map. Field of area 2020. Simply copy after class. It's subtract with before class. So just they put here and then give a function subtract with before class. Before class mainly 1991. One, yeah, this one. Copy. Subtract with that. After that, we are just put here that another thing is that changed not equal to 0. Okay. So in this time, let me check the first the results. So I just simply show the result. Map dot add layer called the changed and click to the run. And we also put here the color, then it's better. Suppose I just put the color 0 and max 1 and display the rated and make the list about that. Where there is the no change, it shows as a white color, and where is the change, it shows as a red color. And also make about that layer name, suppose urban. Okay, so in this time we can get the changed and unchanged. So this type of red color identify about that changed. So mainly is the expansion about that. And this type of white color identify about that there is the no change only for the urban class. So in this time we are just talk about that only for that urban class, not for the all of this class, only for the urban class. So here you can see in the middle we can get the white pixel because there is a no change. Okay, suppose for the before in 1991